Hello everyone, welcome to Clash Encoder. So in this video we will see the question that is two numbers with odd occurrences. So this is a easy level question, but it has been asked in various interviews for Amazon, Google, etc. So let's see what is this problem statement and how we can solve this. So given an unsorted array of size n and that contains even number of occurrences for all numbers except two numbers. So that means all numbers occur even numbers of time except the two numbers. They will occur two odd numbers of time. So find two numbers in decreasing order which have odd occurrences. So we have to find the numbers in decreasing order. So we have to find the two numbers those have odd occurrences and print them in decreasing order. We don't have to find them in like decreasing order. You can see we have to print them in decreasing order. First 5, then 7. So then you can see we will be expected time complexity is O of n and the extra space that we will have to use is O of 1. So I will explain you all the solutions starting with the naive approach to the most optimal approach that will satisfy these constraints. So the input will be given simply the test cases, then the number of elements in the array, then the elements of the array. Let's see how we can solve this question. So actually, if you didn't understand, so we will be given this type of array and we will have to find the elements which occur only odd number of times. So here you can see 4 occurs, you can see 2 number of times, so it is even. Here you can see 2 occurs 2 number of times, but here you can see 5 occurs 1 time only, so it should be printed. So here 3 occurs 2 times, so it cannot be printed, so that means it is even. So here you can see 1 occurs again odd number of times, so we have to print 5 and 1. So you cannot print 1 and 5, you have to print 5 and 1 only. This will be wrong order because it is written that we have to print the elements in decreasing order. So for solving this question, the naive approach that you can start with the interviewer is, so you can tell him that you can simply run 2 for loops. First loop will like select one element, and the second loop will count the occurrences of this element. So it will count the occurrences of element. So second loop will run from here, so it will count the occurrences. So first C is 1, okay, it will count here 2, 3, and similarly for every element you will run 2 loops actually to calculate all the possible cases, and you will run 2 for loops, and then you will calculate for every element the number of count it is occurring. If it occurs odd number of time, you will simply print that output. So that will simply naive approach. It will take O of n square time because we are using 2 for loops and O of 1 space. Let's see the more optimal solution than this. So the most more optimal solution that you can use is you can simply sort the array because we are given an unsorted array. So if we sort this array, all the occurrences of the elements will occur together. So what we can do, we can check for every element if it occurs odd number of time or not. If this element is here, okay, we will check if this previous element, or look like you can check yourself. So how we can solve this? It will be simple actually, you can implement it easily. So this will be n log n time because time complexity, because you have to sort the array. So for sorting the array you will use actually the merge sort or the quick sort, okay, inbuilt function. So you will have to sort it, so it will take n log n time, and the space complexity will remain O of 1 because you are sorting in place. So you will have to just count the occurrences and the print the element which is occurring odd number of times, like this 5 and 1. So this will be the another solution, and more optimal solution for instead of this n log n time complexity, if we compromise on space, we can optimize it further. So that will be using hashing. So actually, if you don't know, hashing is a simple approach. In Python it is known as dictionary, in C++ it is known as a map. So it is simply a key value pair. So key is actually the element that we are having. So if we are having 4, so it will be the element. So keys should be unique here. You can see keys are unique, but this value that is 1, here you can see 2, 2, 2. So it is the number of time it is occurring. So we will traverse this array and we will make a hash map and we will insert this 4. Okay, it occurs how many times? First it occurs 1 time, so 1 will be saved. Then you can see it has again occurred, so it will be set to 2. So you can then get all the count of the elements that are there. So then you can simply traverse this hash map and you can simply count, check modulus 2. You can do value modulus 2 and you can check if it is odd or even. If it is odd, you can simply print it or add it to the result, and if it is even, you can simply skip it. So this will be using hashing, and it will take O of n time because you are traversing the array, then you are traversing the hash map, but the space complexity is compromised. So it will take O of n space because we are storing a hash map. So it will take O of n space. So this will be optimized solution, but the most optimal solution that will use this given constraints will be using XOR. So first we will see what are the main properties of the XOR that we will be using. So let's see. So the XOR is actually, you can see these properties that I have written. XOR of a number can be done by simply, you can see this A XOR A is equal to 0. So that means if a given number is 1 and this 1, so 1 XOR 1, this is the sign of the XOR actually. So 1 XOR 1 is actually 0. If the elements are equal, so XOR is 0. If it is 1 and 0, so it will be actually, you can see a number XOR 0. Let me erase this, sorry. So number from here you can see a number XOR 0 is always the number, output is number. If number XOR number itself, then it is 0. So this is a property that we will be using. You can see here, if number occurs two times, so the output will be 0. But if number has occurred one time, okay, it has occurred 2 times, so output is 0. So now again, if number has occurred, that means if it has occurred 3 times, so it will be A XOR 0. So that will be A. So output will be A. So that means it has occurred odd number of times. So we will be using these properties actually. So if you see, this is XOR properties, associative and commutative also. So you can see, if we do A XOR B, so it will be equal to B XOR A. So that does not make any difference. So in this array, if you try to do XOR of all elements, so if you try to do XOR of all elements, if you see 2, okay, this 2 and 2 will be cancelled because they occur even number of times. So even this A XOR A, that means 2 XOR 2 will be 0. So if you do 1 XOR 1, so it will be also 0. So you will be left with 3 and 5. So these are the all odd elements. So we'll see how we can calculate this, but I hope you got the basic properties of the XOR first. Now if you see, if we are given like 1, 0 and 1, so its XOR will be 1. And if we are given 1 XOR 0, so its XOR will be also 1. If we are given same numbers, 1 XOR 1, it will be 0 actually. If we are given 0 XOR 0, it will be 0. So these are the 4 properties of the XOR. Actually, the table of the XOR, you can see 0 XOR 1 will be 1, and 1 XOR 0 will be, if both elements are different, both values are different, XOR will be 1. If both elements or the values are same, that means 1 1 or 0 0, so XOR will be 0. So we will be using this property. Like, see, you can see here, if we do this 0, we do XOR of 1 and 2. Okay, we do XOR of 1 and 2. You can see here 1 and 0 are different. So 1, 0 and 1. So it will be 1. From here you can see 0 XOR 1 will be 1 and 1 XOR 0 will be 1. So here if you see 0 and 0, so 0 and 0 are same, so XOR will be 0. So 0 and 0. So this is how we do XOR of two numbers. So now this will be the property, the basic that we'll be using, and I will also tell you that we will have to find the rightmost bit also. So let's see before only how we can find that. So if a number is given, like number is given 0, let's 2. So 2 is this, okay. The binary representation of 2 is this. So now we have to find the rightmost bit of the 2. So how we can do that? So this is the formula that we will be using for finding the binary, the last set bit of the 2. So last set bit is from this side, okay. It is from this side, right to left. So we have to find this one. So we can simply do this one. This x is our 2, okay. X is 2. So this is x, and we have to like find this value first. So let's see, x minus 2. So that means 2 minus 1 will be 1 only. So 1 is this, okay. 1 is this, 0 0 0 and 1. We have to negate it. So this sign is actually negate. It means if it is 1, so make it 0. If it is 0, make it 1. That means toggle. So we will toggle these bits, so it will become 1 1 1 and 0. Now to find the rightmost set bit, we have to do this AND of this number that we have and the value that we have calculated from this negation of x minus 1. So it will be actually, you can see 0, okay. So let me 1 1 1 and 0. Now we will have to do AND of this. So if you do AND of this, all the numbers will become 0. You can see AND is actually, if it is one number is also 0, so output will be 0. You can see 0 0 and here also 0, but here you can see it is 1 1. So that means output will be 1. So by doing AND, we are eliminating all the elements instead of the last or the rightmost one, you can see set bit. So we have got the set bit, rightmost set bit of the 2. You can see 0 0 and 1 0. So yes, this is the rightmost set bit of the 2. For any number you can try and use this formula on the copy pen. I will explain you with a simple example because we have limited number of time. So you can see I explain you this. Now let's see. So I hope you got how we can find the rightmost set bit. So you can try it for another number also. Let's see if we can do that. So like 0, okay. We are doing this for 3. So let's see. So 3 minus 1 will be 2. So we are finding this. So 2 will be this 0 0 1 0. So when we negate it, it will become 1 1. Let's see, 1 1, and this will become 0 and 1. Now you can see again, we will, if we do AND of these numbers, so it will become 0 0 and 0. But only the last or the rightmost set bit will be remaining. You can see 1. So this is a formula for finding rightmost set bit. We will use this formula and these properties. So actually what we will do is, now we know all the properties, so we will be given this array. So we will first try to find the XOR of all the elements. So XOR of the whole elements of the array will be actually, if you try to XOR all the elements, so it will be 2, okay. 2 XOR 1, XOR 3, okay, like this, XOR 1, XOR 2 and XOR 5. Now if you try to do XOR of all the numbers, let me erase this. I will write it here only. So it will cancel. It will get cancelled. You can see 2 XOR 2. So let's see. 2 XOR 2 it will be, you can see 0 0 1 0. All the elements are same. As I told you, when all the elements are same, then the XOR will be actually 0. if all the elements are 0 or same. So you can see if all the elements are same, 0 0, it will become 0, 1 1, it will become 0. If it would have been 0 and 1, then output will be 1. So if bits are same, then output is 0. If bits are different, then output is 1. So that is why this 2 and 2 will get cancelled. Now when we XOR this value, that is 2 and 1. If we XOR this, okay, then we XOR 3 afterwards, then we XOR 1, then also 1 will get cancelled. It is not like we have done XOR of 2 and 1 before, then we cannot do XOR of 1. 1 will not get cancelled. It will get mixed to 2. It is not like that. 1 will obviously get cancelled then also. So that means we will be left with only 3 XOR 5. So our value left will be 3 XOR 5 in the variable that we are storing by XORing all the elements. So it will be actually, you can see 3 and 5. So this will be 0, and let's XOR this. It will be 3 will be 0 0 1 1, and 5 is actually 0 1 0 1. Now if you XOR them, so the value will be actually, you can see 1 1, and it will become 0 1 0, it will become 1 1 and 0. So this will be the output that we'll be having in the X variable. So now we know that we have got the two values that are odd, that are occurring odd number of time in our variable. Now we need to know how we can extract these values out of the XOR. So we will have to find out how we can extract the two values out of this XOR, that is those values XORs. So let me note it here also, here only, that our XOR is actually 0 1 1 and 0, if I'm not wrong. Let's see. So yeah, our output was this. Now let's see how we can, the basic approach or the pseudocode that we will use. So as I told you, first we will find the XOR of all the elements of the array. So you can see this, first you have to initialize this X variable with the first element of the array. So if you don't initialize with the first element of the array, it will actually like mess up with the algorithm. So you will have to initialize with a of 0. Then when you initialize with a of 0 and you XOR all the values, X will be left with this value. You can see it will be actually 3 XOR 5, because all the elements that are occurring even number of time will get cancelled. But these numbers are occurring only odd number of times. So there is no value to cancel this 3. So it will remain as it is. So we will get 3 XOR 5 in this X variable. So we have got this. Now we will find the set bit of this XOR that we have got. So we will find the set bit of this XOR. So let's see, let me erase all this. So we got this as a XOR. Okay, just a second. So you can see we have got this value as XOR, that is 0 1 1 0. So we have to find the rightmost set bit of this XOR. So we will be using this formula in this loop also. You can see after this loop we have calculated the rightmost set bit. So I will tell you why we are using this, but let's calculate first. So you can see how I told you to calculate this. You can see which is this number. So this is 6. So this is actually 6. You can see this is 6. So now to calculate the rightmost set bit, we will minus this 6 by 1. So 6 minus 1 will be 5. So we'll get 5. So you can see 5 is 0 1 0 1. So we will have to negate this. We have calculated this. Okay, this part now we have to negate it. It will become 1 0 1 0. So let's see, 1 0 and 1 0. So now if you XOR this value, if you AND these values, all the elements which have 0 in it will be cancelled. You can see 0 0, okay, 1 1, but this will remain 1 1, and this 1 0, it will become 0, and 0 1, it will become 0. So we have got the rightmost bit. And yes, you can see it is true. So in this 0 1 1 0, so the rightmost bit is this only. So we have got this in our variable, that is 0 0 1 0. So if you try to, now why we are doing this, let's write this also, note this down. You can see the set bit variable will have the value as 0, what was it, 0 1 1, actually yeah, so it was 0 0 and 1 0. So this is the value that we have in our set variable, in this variable. Till here you know what we are doing. Now why we are calculating this value, actually let me tell you the concept, actually why we are calculating this. You will have seen many videos, they tell that we are making the buckets. So actually yes, we are making the buckets, but why am I making the buckets? So let's see. So now if you see, if we have to like distinguish the values in these, so if we have the like set bit variable, let's assume it to be, if we have to calculate all the values, okay, we have to differentiate all the values and make the buckets with which have the second last bit as set. So it will, for that we'll be using this variable, okay, second last bit as set. So we have this one. So now if you try to AND any number with this value, so if you try to AND this value, okay, 0 0 0 and 0, so now you know we have to find the value which has this second last bit set. So if you try to do this, okay, AND this, so it will become 0 only, the output will be 0. If it is 0, so that means it does not belong to that category that we are searching for, which has the second most bit set. So we will maintain a bucket. You can see we have maintained a bucket, so 0 will come here. Now here we need the second last bit is set. So now if you try to do 1 and if 1 is okay, let me write it here. So now if you this variable is okay, we are using that is this. Now if you try to do and with this 1, so again it will be not in the category which has the second last bit as set. It will output will be again 0, you can see. So it will again come to this bucket. Now when you come to 2, so here if you try to and this variable that set variable that we are searching for with 2, now its output will be not 0, you can see. Its output will be actually 1. It will be having one bit at least set, you can see this 1 is set, so it will come here. Like this we can distinguish all the elements between the buckets. Now you can see 3, so 3 will be again, it will be having one at least a bit set, second last bit set, so it will come here. Now for 4 will be not having the second last bit set, so its output will be 0, so it will come here. Like this we are using to distinguish the set variable, we will be using to distinguish it between the values and maintain the buckets. So if one particular element, okay, 2 is coming to this bucket and the second 2 comes, okay, and the second 2 comes, then it will obviously come to this bucket only because the value will be same, 2 is same, so it will get cancelled. So we will as we have this 2, 3 and 5 in one variable, we will separate them based on 2 buckets. We will maintain 2 buckets and 3 will go to first bucket or the second bucket and 5 will go to the another bucket. And the elements that are coming to that bucket, if 2 comes here, okay, 2 comes here as we saw, then when next 2 will come, it will obviously come here, so it will cancel out, and 1 comes here and 1 will come again here, so it will cancel out. So we will be left with only 3 and 5 value, you can see 3 and 5. So this is what we are trying to do. So we will, if as we know, let's see, so we have found this value, okay, you can see this was our XOR of the elements. So we have to find 3 and 5 based on the bits which are different in both. So in the XOR, as I told you, if both bits are same, so the output is 0. If both bits are same, the output is 0. If both bits are different, the output is 1. So at that is why we are searching for the rightmost bit, that is set. So here you can see 0. So that means in both 3 and 5, both bits are same. You can see 3 and 5, both last bits are 1. So that means they are same. We cannot distinguish based on that. So in 1, when you get 1, the rightmost bit, this 1 is 1, so a set. So that means we have to distinguish based on this value. So that is why we are calculating the rightmost bit. So I hope you got the point. So we are trying to distinguish the two values and extract those values out of the variable that we have, the XOR of whole array, based on this value. So let's see how we can do that now. I hope you got all the basic points that I was trying to do. So we have till now we have found this variable set variable and the XOR of whole array. So now you can see we have initialized the first and the second also to 0. So this is the values that we will get, and we will have to return them or print them. So this is the first value and this is the second. So we have initialized them to 0. Now we will traverse the array, and for every element in the array we will try to do its AND with a set variable. When you come to 2, okay, you come to 2, so 2 is actually, you can see 0 0 and 1 0. So if you try to do the set of this AND of this 2 with the set bit, you can see, so its output will be not 0. So that means its output will be something 1. You can see it will be greater than 0. So if the value is greater than 0, it is always true. In the C++ or any programming language, you would know that if we pass any value greater than like 0 to if condition, it will be true. So that means if this is greater than 0, then we will XOR this value with the first value, that is first variable that we are maintaining. So we will XOR it with the first variable, so it will be 2, and the second will be still 0. Okay, it is still 0. So now when we come to the next value, it is 1. Okay, this condition will be skipped. If this is if else, so this condition will be skipped. So now we can come to 1. So 1 is actually, you can see 0 0 and 0 1. So if we try to XOR of the this AND of this 0 0 0 1, so now if you do try to do AND of this, so it will be actually 0. You can see all bits are different, so all bits have 0 in them, so you can see the output will be 0. So that means 1 is not in this part or this bucket, so it will be coming to the second bucket. So we will this part will be true or false actually. If and here the value will be 0, so this will be becoming false. So we will come to else part, so we will XOR it with the second variable. So here the value will become 1. So now when you come to 3, as we saw, if we try to do 3 XOR this and this value, so you can see here the second last bit is set. So that means value will not be obviously 0. So if it is not 0, it will be true. So it will be entered into this. So you can see it will be first XOR 3. So first XOR 3 will be 2 XOR 3. Actually, you can say 2 XOR 3. I am not writing it into binary representation. As I know, you can do that. You can do it. So we will like keep it simple now. So when we come to this value now, you can see 1. So again, as we saw, 1 will come to the second bucket or the second variable. So you can see 1 1, so it will get cancelled when the two values are same. They will their XOR will be obviously 0. So second has 0 now. So that is what we were trying to do. Now we will be left with only the value. You can see now when we get 2 now, okay, we get 2. So 2 is in second bucket, first bucket, we know that. So it will come here. So now 2 will get cancelled. So we will left with 3 in the first bucket and the 0 in the second bucket. Now when you come to 5, you can see 5. So 5 will come, you can see 5 is here. So when you try to do this AND of 5 with the value that we have, you can see if you try to do AND of this 5 with this value, you can see it will become 0. You can see it will become 0. So all the values are different. So it will become 0. So it the value here will be saved. You can see 5 will be saved in second. It will be XORed with the second. So second is 0. So as we know, 0 XOR any value will be that value. So it will become 5. So you can see we filtered these values based on the rightmost bit, which was different in both the variables. So you can see on in 3 and 5, 3 is this 0 0 1 1 and 5 is actually 0 1 0 1. So these bits were same, so their XOR was 0, but these bits were different. So that is why how we got to know that, because if the elements are different, then only XOR will be 1. So that is why we used this rightmost bit. We found the rightmost bit using this formula, and we used it to find the differentiate between them using the two buckets. And when we try to make two buckets, the value that is 2 will come into same bucket. So when 2, if we know that only 2 elements occur odd number of times, so we have differentiated them based on the buckets. So when 2 occurs in the first bucket, so next 2 will also go into that bucket, so it will cancel out. If it occurs again 4 times, if 2 occurs, so that means it is even, so it will again cancel out itself. So only we will be left with the odd values which are occurring odd number of times. So that is 3 and 5. So let's see the code. So the code will be similar to the pseudocode that I've explained. So here you can see I have taken the input of the test cases. This is actually to increase the time of the decrease the time of taking input and output. So here I am using this while test case minus, then we are calling this function, and let's see. So in this function, first we have taken this inputs, then we have initialized the XOR to array of first element. As I told you, don't forget to initialize with the first element. Then we find the XOR of whole array. Then we find the lastmost or the rightmost set bit on the this XOR value. You can see XOR and negation XOR -1. If you don't get this, you can rewind this video and watch this. I have explained how we can find the rightmost bit of this, how this formula is working. So then we will initialize two variables. This is the first and the second that we have to print. Now you can see we will run a for loop, traverse the array, and we will check if this rightmost set bit and the particular value is 1, that means it is greater than 0 actually, then it will be true. So we will save it into the first bucket or the first variable. If it is false, that means it is 0, then we'll save it to the second bucket. At the last, as we know, we will be getting the two values that we were searching for, odd values, but here we have to print them in decreasing order. So we will check if x is greater than y, so we will print cout x first, then y, else if y is greater, we will print y and x then. So let's submit this. So actually I hope you got the solution. So I will share the solution in the description, the code in the description, so you can check it from there. And the time complexity for this solution will be just O of n, because we are only traversing the array, you can see 2 times, so it will be just O of n, and the space will be O of 1, because we are just saving the XOR in some variables. So we are just using 3 variables. You can see 4 variables actually, the XOR, and so that won't matter. So it will take just time complexity of O of n and O of 1 space. So you can see it got submitted. It took just 0.1 second, 0.0 second. So thank you for watching, guys. Do like this video and subscribe to the channel for more such videos. Thank you for watching.